All right. All right. Hi, everyone. Thank you so much for joining us for the Intro to Databases workshop sponsored by Caterpillar. My name is Shrestha, and I'm part of the HackIllinois staff. Today, we have with us two student organizations at UIUC to present the workshop. So Hack for Impact UIUC is a student-run organization that works with nonprofits to build products for social change. And Women in CS is a group dedicated to supporting students in CS and tech by providing them with technical and professional development opportunities. So huge thanks to both of these organizations for putting together the workshop and to Caterpillar for sponsoring it. And so I'll let Hack for Impact and Women in CS take it from here.
Yeah, like Shrestha said, thank you so much, guys, for showing up. I'm Sophia. I'm part of the Women in CS team here at U of I, and we're just going to be going over a quick MongoDB tutorial. It's going to be in the form of a treasure hunt. And yeah, so Ian, if you want to maybe talk a little bit about it.
Or, for sure. Yeah. So my name is Ian, and I'm a tech lead on Hack for Impact. I'm sure we'll introduce ourselves as we maybe speak. But yeah, the kind of format of today's presentation is we're going to teach you guys about MongoDB, teach you how to use it and what it's all about. And then we're actually going to get our hands dirty by completing this treasure hunt. And that'll be in the form of a crossword puzzle querying a database. So it'll be really cool. Hopefully you'll leave today with some really tangible MongoDB experience. I think that should be good to get us into it. I guess, how about this? Let's introduce all the Hack for Impact and WCS members before we get started. So you've met Sophia and me, but let's start off with WCS. If you guys can just say your name and what you do.
Hi, my name is Esther. I'm a freshman studying stats and CS, and I'm part of the WCS technical committee.
Hi everyone, my name is Shreya. I'm also a freshman in CS and I'm on the WCS Technical Resources Committee.
Go ahead, Grace.
Hi, my name is Grace. I'm a freshman in CS and I'm a software developer for Hack for Impact.
Hi guys, I'm Jessica. I'm a freshman in computer science, and I'm on a team called 7,000 Languages as a software dev for Hack for Impact.
Cool. I think we should be ready to get started then.
Okay, awesome. All right.
Yeah, so we'll start off by talking about what is a database. So a database is an organized collection of data or structured information, and it's typically stored electronically in a computer system. These databases are usually controlled by some kind of database management system, which serves as kind of an interface between the database and its end users or programs. And some examples of this that you might have heard of are MySQL or Oracle database. And there are several different types of databases as listed on the screen.
And so as a semi-real life example, you could pretend that you're a doctor and you want to keep track of your patient's data. And let's say you have the first name, the last name, and the ID, and your patient's name is Taylor Swift. But this is just one patient's data. Let's say that you want more patients' data, but now you're interested in maybe finding what their phone number is or their zip code. But let's say you don't know what Taylor Swift's zip code is or their phone number is. So now we run into this problem of having a lot of empty spaces in your relational or in your spreadsheet. And this can become a really big problem when you have a lot more patients in your database. And so right now we're looking at something called a relational database, which is a database that is organized in the form of rows and columns. And you can see that there's a lot of unused space here. So what MongoDB essentially does is it organizes your data into files instead of rows and columns. So now we have one file for one patient, and you don't have to have every single column's information on this file. So if Taylor Swift didn't have a phone number, you wouldn't have to put that on her file. Okay, yeah. And then just as a quick summary of MongoDB, it's documented oriented. It's a NoSQL database, and it's used for high volume data storage. And like I said before, we used collections and documents versus tables and rows. And like another cool thing about MongoDB is that it allows for indexing. And like I said before, it is high performance. So this is like an example of the object literal on the right. Oh no.
So what does a MongoDB database look like? This is one that you're looking at right now. You can see that there are multiple collections that the database will contain that has different types of data. So you have comments, movies, sessions, daters, and users. And then each of these collections will further contain documents that follow the same sort of schema. And a schema is basically a JSON object that kind of defines the structure and the content of the data that you'll be storing in this database.
Going a little bit deeper into what documents are, documents represent entries in a collection and follow an object-oriented structure. They also contain key value pairs rather than rows and columns and are tracked using a unique ID field. MongoDB automatically generates unique IDs for your documents, but if you want, you can override them and generate your own. And below, you can see an example of a document. It has 4 key value pairs, and you can't see it there, but it also has a unique ID field.
Cool. So you've seen some documents and collections in action. Here, more specifically, the documents we'll be working with today. So our whole database is about movies. So here's the movies collection. You can see we call it a collection because everything in that collection will represent a movie object. So that involves a title, a director, a rating. And you can see, right, how nested MongoDB can be. That's because it's an object-oriented document, not a row column relational database structure. So this really bodes well to real world data where it's not really one-to-one. Maybe it's more nested and layered. You'll see on the top, we have that unique ID field. And then a lot of these parameters then are, for example, arrays and not just, for example, strings. So you can see cast, for example, is an array of names. You can see genres is an array of strings. So that's pretty cool. You can move on to the next example document that we'll be seeing. And here's a comment. This is something that maybe refers to movie ID. So what's really cool is instead of doing those joins maybe with SQL row column pairs, you'll be using MongoDB ID fields to make that possible. So we're showing that off now so that you can see kind of the whole relationship between different collections and different documents. But you know, the whole idea is, okay, how are you actually going to maybe take this away? That's where we're going to get our hands dirty. So we're actually going to be working with this exact database, this movies database, to do some pretty cool things. So hopefully that gives you a good understanding of what MongoDB is on the greater sense. But if you're a bit confused still, don't worry, because we will talk about it.
So for the activity we're going to be doing, here are some functions and operators that you can use to search through a MongoDB database that you might find useful for this activity. So the first one is dbcollection.find, and this basically returns a pointer to documents that match the query criteria that you pass in as a parameter. So for example, if you did db.movies.find and then you pass in a date, you're then searching the movies collection for all the documents that contain that date. And then the next one, find one, returns only one document that satisfies the criteria in the argument. It'll return the first document that it finds that satisfies that criteria. And then count documents, it returns the number of documents that match a certain query. So for example, if you wanted to find the number of movies that use that have a certain rating, you can use count documents and search for that rating. And then ID is a global unique object ID for the document.
So these are some more important operators that we will be using during the activity. The first two is less than or equal to, and also greater than equal to. So these will filter through the database and find any values that are less than a certain parameter or greater than. In addition, another operator is the and this will join different clauses together and return everything that matches both of those conditions. So here's an example. Let's say we want to look at the inventory and we want to find all of the objects that are either greater than $14.99 or less than or equal to $14.99 or greater than or equal to $1.99. And so these will find all of the objects in between. For example, let's say there's an object that costs $10, that would be part of the sample. Two more operators is the all and the in. So the all operator will find all the elements that meet the criteria within a certain list. So for example, let's say we want to find the objects that have the tags of appliance, school, and book. Then you would use the all operator. The in operator will find elements within a certain range. So for example, in 5 to 15, so it could find an object where the quantity is 9. All right, yeah, let's get started on the crossword. If someone could send the link to the PDF in the chat, that would be great.
Yeah, so basically how this crossword is going to work is that you can like see the questions that are listed below, and then we're going to use the MongoDB database that Hack for Impact created to help answer these questions, like using the operators and functions that we just talked about before. So I'm going to put you guys into breakout rooms. Feel free to like talk to each other, or we're going to have like 2 leaders in each room to like walk you through the project, but just like sit tight for a few minutes while I put everyone into breakout rooms.
Into the activity now, so you're in the right place. So I will share my screen and I'll show you guys a couple of things. First thing first, we got to share the slides. On the slides, if you guys open it up, you will get some really important setup instructions. So I sent that out to everyone. If you guys can do me a favor, let's all go to slide 16. And pretty much what these setup instructions allow you to do is to connect to the database. So we need to install some command line tools. So if you're on Mac, you need to install Homebrew first to get these command line tools. So just copy this command into your terminal. You can open up the terminal using command dot. And then if you're on Windows, it's a lot simpler. Go to slide 17 and click on this link. And then just download the 64-bit installer MSI and click download. Once you guys have done that, the way you can check that everything has been installed properly is if you can go to your terminal or your command prompt if you're on Windows. So the way you do that for Mac is just do command dot, search for terminal. If you're on Windows, go to the bottom left and search for a command prompt on the search bar. Open up a terminal, and then if you have installed everything, you should be able to run just this command, mongo sh. And if you see anything output, you got the command installed. So let me know if there's any not anything unclear about that, but right now that's what we're going to be doing for like 3 to 5 minutes. Hopefully it doesn't take too long. I'm going to open up the chat because I realize you guys might have some questions. Yeah. So what would be really helpful is once you have it installed and you can type the mongo sh command into your terminal and something happens, just send it in the chat. Send me a DM, send it publicly. It really doesn't matter. Just say, hey, I got it installed. So yeah, we sent the slideshow out again. Thanks for that, Sophia. Yeah, so go to slide 16 through 18. Pretty much slide 16 gives you the Homebrew if you're on Mac. Slide 17 gives you the installation instructions. And then slide 18 allows you to just check if you're installed. And actually slide 18 we'll get into more specifically. So 16, 17, yeah, great. A lot of people are messaging me right now that they got installed. That's great to see. I'm going to give you guys like 2 minutes. I realize this can take some time. So just give everyone like 2 minutes to get it installed. Pretty much you'll know if it's working if you can type mongo sh. So I'm going to open up a terminal myself. If you can type this command right now, mongosh, and just if anything pops up, you're good. Even if it says like error. If it says nothing, or if it says error, but like we didn't understand the command, then it's not good. But if it says error, we couldn't connect you to the database, then yeah, that makes sense. Cool. So just keep me posted. A lot of you guys have messaged me so far. I appreciate it. So yeah, 2 more minutes. And if by any means, if anyone's having any problems, so Homebrew is pretty big. So I realize it might take more than 2 minutes, but we're going to keep moving on. Just follow along with me because we'll be leading this workshop kind of together. But yeah, try to install Homebrew if you're on Mac. If you're on Windows, just click on this installer. The idea is if you're on Mac and you have Homebrew installed, you can just type this easy command, brew install mongo sh, and Homebrew is like your package installer. So you can type that command and I'll run it, but I already have MongoSH. So this does the magic of getting MongoSH onto your laptop. Cool. I'm getting some more messages. Perfect. I'm gonna give you guys like 1 more minute because a lot of you guys are already messaging me, which is great to see. And this will be really cool. The idea is by installing this MongoSH command, you'll literally be able to connect to our database and kind of get your hands dirty with MongoDB. I think that's the really best way to say I've learned MongoDB is actually saying I've ran some commands. And hopefully that this activity will allow you to say that. Cool, yeah, let me know if you have any problems finding the terminal or command prompt. It should be easy to find, hopefully by searching, but I realize this might be new to some of you, and that's okay. We really won't have to do too much with like programming languages today. That's why MongoDB is really cool. It's kind of a really simple thing to get your hands on. Okay, I think it's been like 2 minutes, so I'm gonna get started. Maybe here right now, message me if you're having any problems, but if you're still installing, we can just move on to the activity and just follow along while things are installing. But now for everyone who's got MongoDB installed, we're going to go to slide 18 now and copy this last command. It's called MongoSH all the way up to Hack for Impact. What this command will do is allow you to connect to our database using the username Hack for Impact that we've created for you guys. Yeah, I'm going to send in the chat. Good idea. So in the chat, it's broken up into 2 commands. The first command is what you're going to type into your laptop, and then you'll notice it'll ask you, or actually I said that to Brandon, my bad. In the chat, it'll ask you, in the terminal, it'll ask you for your password. That's where you're going to want to type WCS. So type those after it gets queried. So let me do that with you guys as well. So what this command does is it connects you to the database. And then from there, you're ready to pretty much query for the different parameters. So exactly like I sent in the chat, copy that first command. And then you run it, it asks you to enter your password, type in WCS. Once you're connected, send me a message. And if you're not able to connect, send me a message as well. And if like 2 or 3 people send me a message, that's okay. Not everyone has to send me a message. But just let me know if you guys can connect. So yeah, use that message from the chat. This is pretty much all the setup we need. So after we've done this, we're ready to get started with the actual fun workshop and getting into the crossword puzzle. Okay, cool. Some people are connected. Yeah, you know you're connected if it allows you to run commands. So you'll see the name of the database, sample mflix. That means you're connected. Okay, cool. A lot of you guys are getting connected. I like it. So I guess the one last thing we can send out, maybe we already have sent it out, is the actual crossword puzzle. Maybe Sophia, can you send that one more time?
Yeah, I'll send everything one more time.
Yeah, perfect. Yeah, so we've sent out the slides. Yeah, if you're just coming in, I'll get you back up to speed. We're sending out the slides. Follow slides 16 and 17 to install MongoDB onto your laptop, and then follow slide 18 to connect to the database. Cool. It looks like a lot of you guys are connected. So we're going to get started. So I'm going to open up the crossword puzzle. So you guys should see this on your screen as well. The idea is we see all these clues, right? How are we supposed to use these clues? We're supposed to use these clues to come up with the queries that we will use to search our database. So let's be more specific. How can we turn these clues into queries? The idea is we're going to be using things that we talked about earlier in the activity. So if we can go to slide 12, and honestly, you guys don't need to go to slide 12. I will go to slide 12. We have really 4 main functions and 3 main functions that we're going to be wanting to leverage today. The find one, and the count documents command. These are really powerful, pretty much MongoDB search functions that allow you to learn everything you want to know about a specific document, about a specific collection, and about a specific piece of data. So I think the best way to explain it is just for us to answer a specific question. So I think Sophia sent it in the chat. Really, really good. Or thank you for that. We have the cheat sheet open. Okay. The cheat sheet is going to help us structure these queries. And I think it'll be good for getting started with these activities. So let's try to do the first question, which asks, I'm going to open it up one more time. How many movies in the database are rated TVG? So how many movies in the database are rated TVG? So the way we're going to want to see this is we're going to figure out, okay, we have to answer a couple questions first. What piece of data am I querying? So this is the movies database, right? But if we want to specifically look at a movie object, then we're going to want to query the movies collection. So we're going to be querying the movies collection. And then from there, we're going to want to look at the structure of a document in the movies collection and ask ourselves, how can we figure out the rating of the movies collection? So does anyone have any ideas based on all these different fields? IMDb, year, genres, rated, title, languages, writers, type, Numflix, comments, cast, directors. What fields from the following can we use to figure out what the movie's rating is? If you guys can send me that in the chat. And hopefully it should be pretty clear just from the naming of the object. So we have it in front of us, the Avengers. I'll ask you this, how do we know what the rating of the Avengers is? So hopefully it should be pretty clear. Is it like title? Probably not, right? Is it like year? Probably not. Anyone have any ideas how we can figure out what the rating on the movie is? And you can send this just generally in the chat. You can say it out loud if you guys want. What parameter are we going to use? Okay, let's not worry about it. I'll give us the answer for this first one. It's going to be the rated field, okay? And that's clear from this one in that the Avengers was rated PG-13. In this sense, we're not going to be wanting to find PG-13 movies. We're going to be looking specifically for TVG movies. So we know pretty much everything we want now to run this query. So we're connected to the database, right? From here, we can create our query, okay? So the way you're going to want to query the movies database is do db, and then we're querying the movies collection for specific movie objects. So db.movies, and then let me ask you this. We want to get a count, right? So does anyone have ideas what function we might want to run out of the following three functions? The find, the count documents, and the find one. Which one makes the most sense for getting a number rather than a specific piece of text? So for example, if I do find, it'll give me all objects that match my query. Find one will give me the first object that matches my query, and count documents will give me the number of objects that match my query. Okay, cool. Yeah, some of you guys are messaging me. It's count documents. Exactly, right? So let's go back to terminal. We're going to run the count documents query. And then from here, we need to add our query parameters. So we're going to do that in brackets. And then like we said before, right? If we go back to the movies object, we're querying the field called rated. So we're going to do that here in our JSON object. We're going to be applying that parameter string rated. And then the value that we're looking for is TVG. So the way that looks then is that only the objects that have the rated field equal to TVG will pass that query. And then from there, we're running the count documents function. So in the end, I'm going to get a count of all those documents, which gives me the number of movies in my database rated TVG. So if we run that, we should hopefully get the number 59. And then that's our answer, right? So we can go back to the crossword puzzle, and it was 1 down, 59. So hopefully here, here's where you can kind of keep track of your answers. So I would like, for example, bring out my marker, and I would write out 59. For the sake of simplicity, I'm not going to write it out, but you can do like FIFTYNINE, and that's 1 down. So that gets us started, right? We created the number of movies that are rated TVG. That's pretty cool. We have a couple to go to get the answer, but hopefully that gets you excited. And that uses the count documents function. Let's try another one that uses, for example, the find function. So for example, I want to ask, okay, what is the name of the first movie that comes up that is rated R? So this is really cool. We're going to be using that same rated field that we had before, right? Where we want to only accept documents, movies in this sense, that have a rated field equal to R. But in this sense, in this specific question, we're asking not for a count of documents that passes, but we're only looking for the first document, first movie that comes up rated R. So going back to those 3 functions that we're going to be using all throughout this workshop, does anyone have any ideas which one would be the most applicable for getting the first movie that is rated R? Do you want to use the find function, the find one function, or the count documents function? You guys can do the same thing and message me if you feel comfortable. So we're looking for the first movie that comes up rated R. And I'll give you a hint. It's not count documents. So it's a coin flip at this point. Cool. Yeah, some of you guys have been messaging me, and I really appreciate it. No pressure if you engage, but hopefully, if you guys are engaging yourselves, then you're taking away these MongoDB skills. And yeah, a lot of you guys were saying the find one function, right? The special thing about the find one function is that you run it and you replicate it, and you run it on a different machine. It'll give you the same first result. So don't worry about randomness in terms of the first result that comes. The difference then between the find one function and the find function is that the find function is not limited to just one result. It gives you actually an array of movies, right? Because there could potentially be 30 movies in this database that are rated R, versus the find one function, it'll only give you one of those 30 movies. And it's going to be deterministic what that one movie is. So let's run that now. So our query will actually look really similar. I'm going to use the up arrow to copy what we had before. And then remember, instead of the count documents function, we're going to be running the find one function, right? And then instead of a rated value of TVG, I think this question is asking for R-rated movies, a bit more scary. But with a couple quick changes, we have the next query to run to solve this crossword puzzle. I forgot which number it was, but we can run it. And then you notice we get a whole object of data, right? This is the whole movies object, right? I showed you, for example, the movies object for the Avengers, right? This is the movies object for the movie we're asking for. So in the question, we're not asking for this whole movie object, right? That's not really how a crossword puzzle works. We're asking for the name of that movie. So let's go back to this Avengers object, right? The way I could find the name of that movie is from the title field, right? So we can do something really similar, right? The results that come up in these MongoDB queries are kind of like JSON object, JavaScript object notations. So you don't need to know JavaScript to know how to kind of work with these objects. But if you're familiar with any pretty much object-oriented programming language, you'll know that objects have field values, right? So if I do dot name of field, it'll give me the value associated with it. So in this case, I want the title field to get my name, and it gives me the name Psycho. Now, I didn't need to do that fancy title field application. I could have also just scrolled through the entire movies object and looked, okay, here, title is Psycho. But it's just a cleaner way so that maybe if I'm looking for the next genre, right, maybe I'm looking for the G-rated first movie, I don't have to search the whole JSON object. I can get it right away. So we're not looking at a corner week, we're looking at Psycho. So you guys can go back to the crossword puzzle, right? And we were looking at 7 down. So 7 down would be Psycho. So Psycho. So pretty cool. We've already used 2 different functions, and I think we're 20% done. And a lot of this should give us some really good momentum. Let's try a tougher question. So we've used the find one command and the count documents command. Now let's try to use some operators, right? For both the find one and count documents command, you'll notice we were using one-to-one searches. We were looking just for straight equivalence, right? But typically your searches might be a bit more complicated, a bit more nuanced, right? We're not looking for maybe a specific string to show up. Maybe we're looking for a range of strings, an array of strings, an array of actors potentially, or we're not looking for a specific number. We don't need, for example, the number of Oscar awards to be equal to 7, but we want it to be at least 5, right? So the way we can do that is we can look at a question, for example, like number 6, which asks how many movies in the database were released between 1908 and 1916 inclusive. So let's kind of break down this question one more time, right? First, what collections are we using, right? This is movies, so we're gonna be using the movies collection. Next, what function are we using? So a lot of you guys helped me out with the last one. This is a repeat one. It's how many. So what function do you guys think we might be using? The find or the find one or the count documents? It's a how many. I'll go back to the list of functions. Message me. Well, what do you guys think? Do you think it's find one, count documents? We're looking for a number. So hopefully that should make it clear. Okay, cool. Yeah, I see you guys are catching on quick. This is the count documents command once again. So you might be wondering why are we doing this one? The idea is it's a more nuanced count documents command. Last time we were counting the number of documents with the rated field equal to TVG. This time we're actually going to be querying a different field. In this case, we're going to be looking at the year. And then we also have to ask ourselves, how do we apply this extra logic? We're not just looking, for example, for movies that came out in 1908 or movies that came out in 1916. We're actually doing something more like layered. We're looking for example, 9 possible years that this movie could have come out. So the way we're going to have to do that is using some operators. So I'm going to show you guys the list of operators, right? We have, for example, some mathematical operators. So less than equals, greater than equals. We have some logical operators, and all, and then we have some array operators, the in command. Does anyone have ideas? We're looking for a mathematical comparison, right? So we're going to limit ourselves to these two, right? The less than and less than or equal to hopefully achieve the idea of finding movies that came out between 1908 and 1916. So I'm going to get us started by building this query. So same thing before, right? We're going to be doing db.movies to query the movies database. Like you guys said, we're going to be doing the count documents command, and that gives us a count of how many movies came out in the year 1908 to 1916. And then from here, we have to build out our expression. So what I'm going to do is to help us out, I'm going to go to the cheat sheet. And this is something you guys can always do too after we're done with the workshop, while the workshop's still going on. We can look at the cheat sheet to figure out how we're going to structure this. So same thing we've done before is we're querying the year field. So that looks pretty similar, but instead of year being, for example, a specific number, we're actually adding another depth of JSON search. And this is where we apply our operators. So in this example, we're applying the GTE and LTE fields. Now I have a question. What do you guys think these specific values should equal? I'm gonna go copy this into my terminal because this is exactly what we're looking for in terms of structure, but you can see it's not finished. So I'm looking for your help here. So going back specifically to what the question is asking. The question is asking for movies that came out between 1908 and 1916 inclusive. So does anyone have ideas? What do I want my GTE and LTE values to equal to achieve this? And specifically note to the idea of inclusive. Inclusive means that it's not just, it's also including 1908 or 1909, but it can also equal 1908. Yeah, you guys are doing a really great job. So from what I've seen in the chat, we can do a GTE of 1908 exactly, right? So I'll do that. And we can do an LTE of 1916. So I realize this one's a bit tricky, actually. So feel free to refer to the cheat sheet how I got that structure. But what basically I can summarize what's going on here, right? That first layer of object notation, okay, I'm going into the year field of my movies document. That second layer is where I apply the operators. So the value pretty much has to satisfy the requirements of being greater than or equal to 1908 or less than or equal to 1916. And actually not or, this will be an and. So it has to apply both of these. It has to satisfy both these operators. If I do this, hopefully we'll get an error. That usually happens when you're messing around. So in this case, I just don't have the correct number of brackets, if I'm correct. Or actually, no, I just have extra parentheses. So let me delete one of the parentheses and you'll get the answer of 18. So great job. We can go back to this question of 6 across, and then you can do EIGHTEEN. So we've done 6 across. So let me ask some more conceptual questions. There's actually kind of a lot of variety of ways you can do this question. You don't necessarily need to use the GTE operators. Let me ask you this. What happens if I were to do the GT operator? If I do the GT operator, then I'm not enforcing equals anymore. So I need it to be not just greater than 1908, but I need to be actually greater than 1907, right? Because then it'll accept everything from 1908 and on. Same thing before, same thing here. Instead of LTE, I could have also done LT, so not including equals, but then in that sense, I have to be more strict with my requirement, and then it has to be less than 1917. So if I do this command too, you'll notice I get the same answer of 18. So there's really 2 ways to apply this. And actually, for example, you could do a GT of 1907 and LTE of 1916. You can mix and match, although I wouldn't recommend applying different logic. But yeah, that's pretty cool. Nice job. We've gone through a lot of the different structures of problems. I'd say that gives you a really good sense of kind of how to apply querying parameters. I think let's do the last problem here that I think is kind of a really fundamental question, but it's also kind of tricky. And that is number 3. So number 3 asks, which movie did Donna Smith comment about? So you can see off the bat that we use the word comment, right? So comment is going to be part of its own collection. And in fact, there were 5 collections we could choose from. We only wrote questions that come from 2 of the collections, the movies and the comments collection. And the comment collection is very interconnected to the movies collection. So it really plays off each other well. The idea is what we want to do here is we want to look for comments that came from Donna Smith. So the way we're going to be doing that hopefully is pretty similar, right? But instead of doing db.movies, this time we're going to be doing db.comments. So I'm looking for Donna Smith's comments. So I'm looking for one specific comment. Instead of doing a general find command, which gives me all of Donna Smith's comments, let's just look for the first comment that Donna Smith wrote. So I'm going to do a find one command. And then I'm looking for her comment based on her name, right? So I'm going to be using the name parameter, right? So if I do that, if I do name as Donna Smith, then you'll notice I've been kind of mixing up my notation. I've been doing year and name in outside of quotes. I've been doing year and name within quotes. Either one works. So you do need brackets. I've been forgetting those sometimes. But for example, you can put name, you can embed those inside quotes. You can also delete the quotes. For your key value, it doesn't matter. For your value, it does matter if it's within or without quotes, because that's the actual data type that's representing, right? So in this case, name represents a string. I better have it inside quotes, but it could be single or double quotes. So let's go back to this. We're going to be looking for Donna Smith's comment. So if I run this command, this gives me Donna Smith's comment, which is pretty cool. It gives me, for example, her email, what her comment actually said, which is just some lorem ipsum text, the date, when did she write this comment, and then there's cool 2 IDs here, which I think is a really why this is such a layered MongoDB question, is that a document can actually contain not just its own ID that represents its unique document, but it can also contain an ID that represents another piece of data, right? So in this case, ID underscore ID is like, okay, this is my ID for the comment that Donna Smith wrote at 3:47 p.m. But this movie ID is a different piece that's actually referring to what movie was she talking about. And this movie ID will come in very, very clutch, honestly, because we're going to use that to hopefully answer the question, which movie did she comment about, right? That movie ID pretty much gives us the gateway to kind of connect to that movie. So like we've done before, right? I want to get that specific movie ID field. So I can inject kind of some JavaScript into my query to get the actual movie ID field. So you'll see it's just a random string. And this idea is it's unique, right? So these are going to be really funny looking strings, but they work. They give you a unique string for each document. And then from there, the idea is now I want to use this ID to get back the actual movie that it was referring to. So we're going to now go to the db.movies command, and then we're going to do the same find one, right? And then you can notice, right, movies, they don't call it movie ID, right? They call it underscore ID because it's actually referring to the movie object. So if I do underscore ID in my query, I can then copy paste that specific ID field. And we got this from Donna Smith's comment, right? We got this from the movie ID field from Donna Smith. But then if I run this, and then let's just do that title so I can get the name of that movie. Oh, and we have a syntax there, right? I forgot the essential brackets. Give me one sec. So those brackets, they allow you to pretty much figure out to kind of enter the object to get into specific field values. Think of these brackets as like a template object, and that all objects have to match this template. But the other fields can be whatever they want. So if I don't specify, for example, a name here, that means the name can be anything. But the ID here has to be specifically that ID that I've specified. So one last problem. So looks like I got a null object back, funny enough. So let's go back to Donna Smith's comment and make sure I copied it properly. So 573. I think one thing I realized is that it's not a string. It's actually an object ID. So let me try instead of this. So we're going to be doing some debugging together. Funny enough, let's run this command. But instead of looking for a specific string, we're going to be looking for a specific object ID. So I'm going to wrap this 573 around object IDs, and then I think this just allows it to be kind of like a equivalency search. Otherwise, you're trying to check if a string is equal to an object ID, and I think that will always fail, is what I learned today. But anyways, if you wrap object ID around that string, then it actually works. You get a specific movie name, so the informer. So if you go back to the question, it specifies to drop the. So then my answer would be for 3 down, informer. So INFORMER. So this was pretty interesting, right? The way we started this is not by querying the movies collection, but we actually had to start all the way at the comments collection and then read an ID field that referred to a different piece of data, not just the comment ID, but the movie ID. So that was pretty cool. But that allows you, for example, kind of replicate the idea in SQL of joins, for example, where you want to, for example, join data from your users into their phone numbers table. Things where, for example, a user can have multiple phone numbers. So to match that, you need to have a separate table. In this sense, you can kind of use a direct translation. Instead of having joins on like a column, you'll have joins on an ID. And that's what's going on here. So I'd say that was pretty solid. Does anyone have any specific questions that they're working on in the background that they want to talk about? We've done like 5 already. So you guys are halfway there to getting the answer of 10 across. Cool. Yeah. I'll say there's one more interesting operator that we haven't messed around with, and that is the in operator. That's used for figuring out array equivalencies. So I can ask that one, but I also know we'll be wrapping up soon. So I'll get into it, but we probably will not have time to finish this one. So the question that I wanted to ask is, let me look. Who directed the Ace of Hearts? So 8 across. This one's very interesting in that if you look at the movie object, it doesn't have one specific director. It can have a list of directors. And this makes sense in that some movies, for example, have directors and producers in that role. They might have multiple directors. A director might drop out. Same idea with like cast, for example. You don't just have one cast member, right? So in this sense, the way I do this query is I can't just do, for example, db.movies.find one, right? I'm looking for one director. I can't just look for a straight equivalency when I do directors. So what I'm going to need to do is I'm going to need to use the in operator. So the way that's going to look is like I did before. I'm going to inject another level of arrays or of object into my field. And then from here, I'm going to use my in operator. And what this allows me to do is give it a list of possible elements that can fit in my directors list. So in this sense, what director am I looking for? I'm looking for the actual, oh, this is kind of funny. I'm kind of doing this one backwards in that this is actually asking for who directed. So I could do the .directors field. Let's look at, for example, question number 9, which is, oh, actually, no, let's not look at question number 9. Let's look at question 2, which asks, for example, the director is, it's a cast element. So let's do something very similar where we'll apply this to the cast array. So let me just switch this out. So instead of directors, I'm going to do cast. And then off the bat, I'm not going to do all the actors because I don't think you need them all to get this answer. But we can do Tom Hanks, Tim Allen. Let's see if we can get the answer. So Tom Hanks, Tim Allen. The idea is, right, I'm not just looking for a specific cast member. I'm looking for maybe multiple cast members. So that's what this enabled me to do, the in operator. So let's just run that and see what that first movie that comes up and see if that's the correct answer. So that is actually not the correct answer, right? You can see this is not a Toy Story movie that we're looking for. So let me apply a couple more. And I know we're almost out of time. So let me do Tim Allen. Let me do one more, kind of maybe not mainstream. So Carl Weathers. I don't know if he's that famous. Because I realized Tom Hanks and Tim Allen are pretty big names. Let me get rid of that string. So I can get that. Let me try one more operator. So I'm looking for adventure movies. So I can apply multiple searches by doing adventure or genre adventure. And then let's apply that. So I wasn't able to get the answer, but if you apply this properly, you should hopefully get a Toy Story movie. So the idea is you have to keep applying these operators until you get down to one answer. And that should hopefully help you out with that one. But the whole idea we were asking there is using the in operator. And that one's pretty interesting in that it allows you, for example, get multiple options, kind of like how we use the other operators to get multiple options as well. Cool. I think that's pretty good on time for our breakout room. And I realize some other breakout rooms are hopping back in. Cool. So we can just.
Okay, awesome. Yeah. I think we're just waiting on the last breakout room, so they'll join in a minute. Yeah. So yeah, once they join, we'll continue.
Yeah, I'll just like keep the screen shared for now until everyone comes back. But I hope that everyone learned something. We'll send like the answer key in like a few minutes when everyone is back in the breakout room if you want to keep working on the activity. I think everyone should be back now. So if you guys like go into the slideshow and look near the end, we added some more resources for you to learn about databases if you guys want to check those out. So those are pretty cool. So if you have time, make sure to go to those. We're just gonna go over like maybe like WCS and Hack for Impact if you guys want to ever get like involved. But basically, Women in Computer Science is a super friendly and supportive community. And there are a lot of different sectors of women in CS if you want to get involved. You also don't have to just be a woman, like you can be any gender. But we've like ran Dev Ada in the past, like an all-female hackathon. We bring in guest speakers, and then there are a lot of different hubs that you can work on. There's like technical workshops like this that we run. We also teach high schoolers, and there are a lot of like internship opportunities and like being able to speak to like more women in STEM. So if you guys want to get involved with that, just reach out to us or follow us on our Instagrams or socials.
Cool. And then we can explain what Hack for Impact is. So Hack for Impact is a really cool RSO that connects with nonprofits that don't necessarily have the technical infrastructure in place. But we kind of leverage our knowledge of software to build out their, for example, web apps and other technologies that they can use to cater to more audiences, to cater to greater audiences. So it's a really cool thing in that we get really real world technical experience that we can then translate beyond our college experience. But we have, for example, tech leads, product designers, product managers, and software developers. And we always are recruiting at the start of semesters. So stay tuned and feel free to follow us on Instagram if you want to see what projects we're working on.
It's okay if I say something too, Ian?
Yes, go
Hey,
ahead.
this is Kyle from Caterpillar. Thank you guys so much for coming to the workshop, and a huge thank you to Hack for Impact and for Women in Computer Science. I know the breakout room that I was in was super fun and super well conducted. Jessica and Esther, nice job. So I just want to quickly say it was an honor for us to be able to sponsor this workshop from Caterpillar. We are still hiring front end and back end software developers, software engineers. So if that's something you're interested in, we've had back end workshops and like this one and front end workshops this weekend. And we have internship positions for summer 2022 and full-time positions still open as well, and hiring across all years, right? So just because you're a freshman doesn't mean you shouldn't come and check us out and apply. So I'm an analytics manager within Cat Digital, which is Caterpillar's digital technology arm. Just as a quick, very, very brief overview, we're connecting customers' assets from around the world. So machines like the one behind me in my background are out in the world getting jobs done, building infrastructure, building the infrastructure that you live and work in every day with our customers. And we have telematic devices, essentially smartphones on every single machine that are sending us back data from over 1 million assets around the globe. We land that data and we have to house it somewhere. We have to be able to use it. So we've got a connectivity team at the base of our stack. The next layer is a platform, an industrial platform, based mostly off of AWS. So we have tons of data engineers and software engineers who are organizing and building services and landing all of that telematics data that comes back and then enriching it with other data that we have on services that are performed and parts that are sold, et cetera, for customers. Then we have an application layer of the stack that builds web and mobile applications to be able to allow our customers, dealers, and enterprise to interact with all of that data. And then we have what I think is the coolest layer of the tech stack where I work, which is in analytics. So we're trying to transform all of that information that's coming back into new insights and information for our customers and dealers. So if that sounds interesting to you and you actually want to work in a place where the digital world meets the physical world, like I say, we have opportunities all the way from the hardware layer where the data is generated through the backend databases like the ones you've been working with. We're working a lot in Snowflake. If you guys have seen it, it has a lot of really good semi-structured data. So similar to the concepts that you just learned about in MongoDB. And then application side for web and mobile development and analytics, if you like data science, like my team does. So thanks again for letting us sponsor this workshop tonight. And thank you guys for coming and learning.
All right, thank you so much. Yeah, I think also the presenters of the workshop were going to share the answer key to the activity chat if you guys want to do that. And then if anybody else like has any questions about the workshop, please feel free to like put those in the chat and we'll do like a quick like 2 to 3 minute Q&A depending on how many questions people have. Yeah, so if you have any questions, feel free to ask them.
Cool, yeah, and you can take a look at that answer key. If you don't want to give away the answers, feel free to work on yourself and compare later after this workshop's done. But the one answer we will give away is the answer to the joke for the crossword puzzle. So why do object-oriented programmers, why are they so wealthy? It's because of inheritance. So if you do 10 across, that is the answer. So yeah, sorry if you didn't want to know the answer, but that is the answer. Hopefully you get it. And I'm sure you guys get it with your CS128 and CS124 experience. Cool.
Okay.
Yeah, I don't know if we have any questions, but thanks for coming.
Okay, awesome. Yeah. Thank you so much to Hack for Impact and WCS for presenting. We hope you all learned a lot from the workshop that you can use for your projects. And thank you to Caterpillar for sponsoring the workshop. And thank you to everyone who attended. Basically, I'm going to screen share the QR code so that you guys can use it to scan for like scan in the HackIllinois app for attendance. So I'll do that in like just a second. Okay, yeah, just like let me know if this is good or if I need to like zoom in more or anything. Yeah, and yeah, just make sure you like scan this ASAP because it'll expire like 10 minutes after the event. Sorry, give me just 1 second.
Yeah, in that case, if you've scanned the QR code and you don't have any questions, feel free to head out and we'll hopefully see you at some WCS and Hack for Impact events in the future. And feel free to apply to Caterpillar.
Yeah, thank you so much for coming.
Okay, one more time. You guys are awesome. Thank you so much for organizing all this. It was really fun.
Yeah.
Thank you,
Thank you so much
Kyle.
for coming.
All right, I'm going to go to bed because I'm old. I'll see you guys later.
Bye. Great, cool. Sophia, are you able to end the YouTube live stream?